So now let us try to derive the equation of straight lines completely starting from complex numbers. For example, if you have the organ plane and you have two complex numbers z1 and z2. What is the equation of a straight line which is passing through these two complex numbers z1 and z2? Now what is the condition which every point on the straight line satisfies? So if you take z as a general complex number on the straight line. So as you can see, the arguments of z minus z1 and z minus z2 will either be differing by 180 degrees or they will be exactly equal. So if z is here, z minus z1, that is this vector, and z minus z2 is again this vector. Both of them will be in the same direction or they will be exactly opposite. So can I write that argument of z minus z1 by z minus z2 is either 0 or pi. Argument of z minus z1 by z minus z2 is either 0 or pi. This implies one way to understand this is z minus z1 by z minus z2 is z minus z1. Instead of writing z minus z2, you can write z2 minus z1. This is also okay because z minus z1 and z2 minus z1 also are in the same direction or they differ by an angle of pi. So z minus z1 by z2 minus z1 is purely real. This implies z minus z1 by z2 minus z1 is equal to some real number k. This implies z is equal to z1 plus some parameter k times z2 minus z1. This is the parametric form of straight line. Parametric equation of straight line. So what did we see? Argument of z minus z1 and argument of z2 minus z1. If you take any point z on this line, the argument of z minus z1 and the argument of z2 minus z1 will be either same or they will be exactly different by 180 degrees. That means this complex number is purely real. So I can assume this as a real constant k. So z will be equal to z1 plus some real constant. This is a parameter. That is, if you put different values for k, you get different values of complex numbers on this line. So z is equal to z1 plus k times z2 minus z1. This is the parametric equation of straight line. Otherwise, you can also think of it like this. Z minus z1 by z2 minus z1 is purely real. That means the complex number is equal to the conjugate of the complex number. If a complex number is exactly equal to the conjugate of the complex number, that means that the complex number is purely real. So these two conditions are exactly same. So this implies you have on cross multiplication z times z2 minus z1 whole bar minus z1 times z2 minus z1 bar is equal to z bar times z2 minus z1 minus z1 bar times z2 minus z1. So this can be simplified as z times z2 minus z1 whole bar minus z bar times z2 minus z1 is equal to z1 z2 bar minus mod z1 whole square minus z1 bar z2 plus mod z1 whole square. These two are getting cancelled. So that is equal to z1 z2 bar minus z1 bar z2. So this is the equation of a line passing through the points z1 and z2. So there are different ways in which you can express the equation of straight line. So this is the 2-point form of the equation of straight line.